Okay. So welcome to day 2 of QuickPass. I hope the first lecture was it was quite a bit, and it opened your eyes to several things you're going to learn throughout this course. Again, it was more of like a overview of a lot of the data types, and then just writing variables. But there's still plenty more to cover. Before I get into the review, I did want to kind of just talk about a couple things. One, I'm not going to use Replit in my lecture anymore. I just feel like a Jupyter Notebook is a bit better for displaying information for students. There's no need to use Jupyter Notebook at all. If you're interested, I can share some resources that you want to take a look at. But there's advantages of Jupyter Notebook with using cells that really helps kind of highlight highlight concepts in very structured ways. And so I'm going to use that instead. Let me go ahead and share my screen real quick. I gotta find it. Then it's going to be this one here. All right. Thumbs up or just let me know if you can see my screen.
Good to go.
Good to go? Outstanding. Okay. And so really just want to highlight some things with Python just in general, just to kind of make sure everyone's on the same page when we talk about certain things. And mostly it has to do with like syntax. Really just general concepts here. And one of the things I wanted to cover was, and I did mention it last lecture, is, we have these, variable names and how we use an underscore, that snake case in those variables. And you assign values to variables using the single equal sign. Remember, the double equal sign is it's for comparison. So in this case, I can make several variables and I can, put any information I want in those variables, and then they will be assigned to that in memory. Another thing about Python that I really didn't cover was that indentation is really how you divide code up in Python outside of structuring things into functions. In this case, I did write a sample function, and some of you may not know what this function is or how even to write a function. We're going to have a whole section on functions, but I did want to just kind of illustrate that indentation in Python matters. And in this case, I'm tabbing over one so you can see what code is under what and how it works. And so in this case, I have a function that I've named my super awesome function, and it has a parameter. That's another kind of key term in Python you want to understand because you'll be using them quite a bit when you make functions. If you look though, all this text under here is indented, which means it's underneath this function. So this would be code that runs kind of separately from your main code script. And if you
That's
look,
horrible.
And if you look here, you have an if statement and then more indentation because I'm only wanting to run this code if it falls under this condition, if you will. And we're going to talk about conditionals
Wow.
today. And so we'll kind of see, we're going to see how we can come up with truth or false statements on using Python to help build programs, because this is a little function, a little program that can do something and give us a different result based on what input we put in. And that's really the definition of a function. And then lastly, I have, actually, you can see a few of these now, these comments here. They're grayed out on this IDE. Some other ones turn green, just like Replit does. Some don't do anything. You just have the comment line. Maybe they'll put things in italics. There's different responses to it, but just know that the hashtag here in front of it is kind of the signifier for a comment. And, with developer speak, when someone says, hey, oh, just
Yeah,
comment
like
out
that.
line 4. Commenting out means, you want to put that little symbol in front of it to make the line a comment, so the Python doesn't read that code. It's a very strong tool in troubleshooting when you're running code and you're like, why am I hitting this condition? I shouldn't be hitting this condition. So you comment it out and see what happens if you run it again with that commented out. So comment out
Yeah.
is a common term that we use in that.
Hey, Aaron.
Yeah.
Um, I was reading and like just going on YouTube, And for those who are experienced, like I heard that commenting is like pretty critical in the position at like just it's just very like important to have that like practice to comment. Is that something that you found in your career? That's
Yeah,
true.
you'll
Like
want to.
commenting out is pretty significant and like understanding and continuing to do so throughout your career is pretty important.
Yeah,
So that
yeah.
like yeah.
Yeah, that's one of the like it's one of the design principles in Python. When you're writing, way more complicated code than you're not going to see here, um, you're going to want to have comments. In fact, you'll have these things called doc strings, which really explain a function like, hey, this is the function, here's what it does, here's what it takes as inputs, and here's what it should output. And you have it all listed above the function itself. So other people can read it and see, they can see it and understand what that function is doing instead of having trying to figure out all the variables themselves. So yes, commenting out things is going to be very important. But in troubleshooting and also describing your code, because again, Python is human readable as well. So you want to be sure that people can read and understand it. Um, so again, you can see all these different comments I have in here just to kind of explain, hey, indentation matters. We're indenting here, and then functions here are called this way. So when you write a function, you have the name of your function and then your parameter, which is this right here. So this is kind of gets turned into this when you call it, and we'll go over that. Okay. So yeah, I just wanted to kind of highlight those things as far as like syntax goes. And then you probably saw like an import statement up here on your replit. You have from answers, and somebody has a hot mic. Let's go ahead and turn that off. Also, a reminder if when you come in the room, sometimes you don't have it defaulted to mute. Please try and mute yourself if you can. That will help keep the recording clear whenever we post it. So you saw like this import here. There's like an import statement at the top of the file. What this is doing, and there's a lot more importing that happens in Python just with this, but in this case, there's actually a separate Python file called answers. And what it's doing is we're importing something from answers, and it's a variable called answers. And that variable, if you look at this open bracket, that tells you that this variable is probably a giant list. And sure enough, it is. There's the closing bracket for that, the main. So it's a list that contains several different types of data in there. And if you look, we have another list with some items, and then a list below it with one additional item. And you can guess that it's gonna align with the questions that we have in the main file. So um, so with that, I mean, did anybody have just a really, really hard time with the first assignment when it came to the replit? And again, these assignments are not mandatory at all. They will help you, but I just wanted to know: does anybody have any specific questions on some of these? I promise, as you go along too in this course, you're gonna look back at it and be like, "Oh, okay, that was pretty easy actually. Okay, I understand it now." So, if you ran into difficulties in this assignment, that's fine. We're gonna, it'll become a lot easier for you as you go through this course. But did anybody have any questions that stood out, like specific questions? We can spend about 5-10 minutes on this.
I know Athena and I had questions. I have another question aside from one Athena has, but she can go first. I have another one.
Okay, yeah, yeah. We can go ahead with a single question. I see Tim posted a few questions on here, but I don't know what you're asking here. So it's assertion two, and you can come off mute and explain if you need to, Tim.
After 10, can we go to it's the assertion. It's under 4 under integers. It's
Uh,
assertion number 1.
Okay, so it's this one right here.
So yeah, so in it says let me move this chat. So it says create an integer variable name number of apples with the value equals 10. So you put in 10 as the value. And then it
Mhm.
says so test case pass number of apples that equals is that number mean that it should be 6? I mean, wouldn't that
No, and so this is where like you have to think we're importing
that's
a
the
variable
integer.
called answers. So if you go here and go to answers, and then remember with lists, we count indices starting at 0. Really, this is just a
Oh, that's how
list of,
you
so
read that.
this is 0, this is
Oh yeah.
1, then 2, 3, 4, 5, and then 6. This is index 6
Oh
of the list answers. And what
yeah.
it's saying, this is just a truthy falsy statement, which you're going to learn today. Really,
Yeah.
this is going to give you back a true or a false if those two match.
Got you. Okay. I mean, I understood what the question was asking, but I just didn't really understand
Mm.
what the line was asking. So, okay, thank you.
Okay. And it looks like Tim is saying, my question is, why doesn't dot index work for tuples? Which question are you at? The one right here? Okay. You answered. Okay. Yep. Yeah, I did 5 in coordinates. Again, I know that's also one thing I also want to mention is sometimes answers can be different. If you get the right result, you pass the test case, that works as well. And so what I was doing is like, hey, it's 5 in the coordinates, and that's false because 5 is not in the coordinates. It's going to come back as the correct answer.
I
Okay.
had a couple of questions.
Sure.
So my first one is test case number 9 for is even equals num apples modulus 2 equal 0. My first thought was to do the num apples modulus 0, and then it said you can't divide by 0, which makes sense. And then I figured, modulus 2 would make it even. And then I'm sort of wondering like the syntax flow of it equal 0, like um
Oh, you're
why does
right.
that
Sorry, I was
um
looking where you were. You were right here, right? Uh,
yes.
okay.
So that's sort of what I did. How does that equal to I sorry, I got the answer correct. I'm just sort of confused on the syntax of how that works out to be, I guess, if that makes any sense.
So you're talking about this is even right here.
Yes.
Okay.
So I put num apples and then I did the modulus thing for 2. And then it would be if the remainder is 0, that would make it even. I'm just wondering about it being I don't know how to phrase my question. I'm really sorry.
Okay. So yeah, so you're saying this was the answer you have, right?
Yes.
Okay. And so what you're saying, basically, you were making right here, you were making a conditional statement. And you were saying, hey, my number of apples, whatever it is, if you do a modulo or modulus, which is a finding a remainder, if you will, um, in this case, if the number, if you do any number modulo two, and it ends up with a 0, it's an even number. If you end up with a 1, it's an odd number. That's how it's always going to work because you can only put 2 into even numbers evenly. So what you said here was, hey, um, num apples modulo 2, uh, is that 0? And that's going to equal a true or a false. This right here is a true or false statement. And You said this is true. And so now is even equals true, basically is what that means.
All right, that actually does clear up some stuff for me, so thank you.
Okay, you're welcome.
I do have one more question. I have not been able to get this one right. Darn, hold on, where is it? It's the task increase the count of orange in fruit counts by 2. So that's where the test case 17.
Test case 17.
And sorry for my kid in the background.
That's fine. I don't know where you're at here. Let's see.
It's towards the bottom. It's like the third
Line
Oh,
120.
bottom.
yeah, right here. Okay. Okay. I'll have to do some quick. Okay. You just get the answers.
Do you want to know what I currently have, or are you just gonna explain like what happened?
I can explain it real quick because we do need to
Okay.
get started on the lecture here in a second. Too many curly braces. Okay. That's not right. Hold on. Apple. Orange. 3. And banana. There we go. Okay, so here fruit counts, and we want orange, right? Check if kiwi is a key. Kiwi has a key in fruit counts. If kiwi is a key, okay. That we can go look up again. You said it was 19? Or was it, which one was it again? I'm sorry.
It was the one that you just did, the with the plus equals 2.
Uh-huh.
So
Okay.
yeah, that one.
Okay. Yeah, so what I'm doing here, you can do it several ways. You can do fruit counts, orange, and you can say equals. You can just say it equals, 5. You can just do it in your head, or you can do plus equals. What you're doing then is you're getting the key and you're changing the value by adding the 2. So this plus equals is kind of the way we do incrementing, and you'll see that also a bit later. All right. We can get back to everybody in the chat. Let's go ahead and get move into let's move into the lecture, and then at the end of lecture I can go over this first and last name, because that one does involve functions, which is a bit, we haven't really covered functions all the way. So we'll get into that at the end after we get through lecture. So for today, we're going to go over conditional flow and truthy falsy values. And so this is a pretty important concept when it comes to writing scripts and making decisions, because everything a computer program does, and I think I mentioned this on Monday, everything a computer does, you have to break it down all the way into yes or no questions. Every decision that the computer program makes is going to be driven down to a yes or no question. When someone logs into a website, when they put their email and their password in, that email and password gets packaged up, sent over to a server, and then it gets read by a backend, and it's going to get verified against what the database has for a password and username. So you're going to check, see if the user exists. And there's logic in there saying, this email is the email, it gets passed in. Does this email exist? And then it's going to do a database query and say, yes, it exists. It's going to get the yes back, and it's going to do other logic. All those things happen behind the scenes when you log in, and it's still pretty fast considering how many decisions there have to be made on all these. And this is really the bread and butter of it. How do you write this stuff? How does this happen? And so that's where this lesson comes in. And with Python, with other languages, there are ways to say whether something is true or not without actually saying the actual boolean true or false, because you can make statements. And if it's not a true statement, like 1 is greater than 2, like that's not true, that's false, a computer will determine that and then make a decision if that's your conditional statement. And so we're going to go over those conditional statements, and we're going to talk about some truthy and falsy values when it comes to all these different data types that we talked about on Monday, and how can you use those to make conditional statements. And then we're going to move into what's called if statements, which are really where it's really the baseline of where you start to have a program make decisions. Kind of like I outlined in this function here on this Jupyter notebook, where I have if parameter equals happy, do this, else if, do that. We're going to look at that as well. And then we'll dive into nesting our if statements, because you do that quite often as well on more complicated decisions. And then we'll conclude there. So just like I mentioned, those conditional statements allow you to make decisions based on certain conditions. And the most common ones are if, else, and then else if, and it's shortened to ELIF. In JavaScript, if anybody's familiar with JavaScript, you actually write the words else if. With Python, it's elif, and it will it throws you for a loop. If you're doing both languages, you'll do JavaScript, and you should be Pythoning, and the other way around, depending on what you're used to. For me, one of my contracts that I work on is Python and machine learning, and the other one is I'm working on a front-end application for the Air Force, and so I have to get into JavaScript mode or get into Python mode, and I find it easier just to do it one day on one, and then I go one day on the other. Even though I have to split my time 50-50, I split my days up instead of doing it halfway through, because it can throw me off, and it just allows me to focus on something a lot easier. So every value here on this paragraph 2, truthy and falsy values, every value can be validated as true or false. And we're going to show you all those data types and kind of show examples of that, and I'll do that here. So let me go ahead and minimize that. So with integers, 0 is considered false, and everything else is considered true. And the way it's kind of interpreted with Python is 0 is considered, basically false or not there, and then every other number it exists. It means there's some sort of quantifiable number outside of 0. So really not much typing needed, because this is a pretty good example. But 0 is false, and then 1 is true, and then -1 is also true. Anything that is not 0 will end up as true. With that, you can also have mathematical operations that end up to 0. No, a good use case would be like in a banking application, if you will, where you want to make sure you have things balanced. So you have all these variables that when added together, you have a balanced ledger if it all equals a 0. And so you can say, hey, if this equals 0, or if this is ends up being false, then that's what I want. So you could think of it that way. That's a good real world example. On another note here, floating point numbers, 0.0 is considered false, because floating point numbers have to have a decimal point. So if you see a decimal point, it's a float. All of the non-zero floating point numbers are considered true. So it could have 100 zeros, 0.00000, and then a 1 at the end, it's still considered true. So these examples here, I don't think much writing is needed for that. That's pretty self-explanatory. Empty strings are considered false, and non-empty strings are considered true. So if there's content in the string, it's considered true. So if there's something inside the quotes. So if I were to write any string here, and then if I were to run that, nope. That again. Oh yeah. If so if this is true, I want to print true, otherwise print false. You could put any one of these examples in here where it talks about something being true, and it would always end up as true. And all I'm saying is, does this exist? Print true. With list, an empty list is considered false, and non-empty lists are considered true. So here, if it has content, then it's going to be true. If it doesn't have content, it's going to end up false. Same with the tuple. An empty tuple is considered false, and non-empty tuple are considered true. Any questions on this so far? It may be a bit of an abstract concept now, but it will make sense once you start throwing conditionals in there and evaluating whether something's true or false to make decisions. And I have a pretty good example I was gonna show at the end of this, where we're gonna do a calculator based on these conditionals to kind of show how all of that works, and it will allow us to flex a little bit of that problem solving as well. So moving on to dictionaries. Empty dictionaries considered false. Non-empty dictionaries are considered true. So if it has content, it's true. Following the same set, or same with sets. Empty sets are considered false. Non-empty sets are considered true. And then, of course, with Booleans, true is true and false is false. There is a special value in Python. In fact, it's a totally different data type, and it's actually called the none type. And if I were to write that here and run this, I get back a none type. So it's actually a different data type. And the word none doesn't really mean zero. It really means that it means nothingness. So there's a bit of a difference there when it comes to like real data types like integers. It's a totally separate type in Python. And you'll when you're writing scripts in the beginning and you're trying to designate variables, sometimes it's a good idea to initialize them as none until you're going to use them later. And you'll see that later on in the course when we're writing something a little more complicated. We'll designate some variables beforehand and then use our script to change them. Any questions on that so far? Okay, I do have some questions here in the chat. Is none the same as null? Yeah, that does equivalent. So null is used in JavaScript and other languages, but none is basically the same as null. Okay, let's go back to this type of, because really using these, whether something is a true or false is really the meat of an if statement. And so when we're thinking about these different data types, for example, if you have a list of items and your script, or it's dependent on users doing something to that list and adding or subtracting values, such as like a bank ledger, right? Well, or a shopping cart, if you will, like you'll want to have logic in your code. Like if they're going to add items to their shopping cart and they have 10 items, right? But then they start removing things. Once their shopping cart gets to 0 or empty, you want to make sure you have a boolean statement there saying, hey, they can't check out if they have an empty shopping cart. You would actually have logic in your code to do that. And this using if statements kind of helps you structure that. So let's throw in some example if statements here, just like I have here. In fact, I can probably copy this and paste it. We're not going to use a function, because I want to run it without the function header. Also note here, in this case, in this Jupyter notebook, it's telling me there's an unexpected indentation. This is an error that would pop up if I try to execute this code. And it shows up as a squiggly line in this IDE. There's other errors they'll get you, or they'll give you. If I try to run this, it will actually come up with an error and tell me this error, but this, Jupyter Notebook will kind of give me a kind of a preview of what some error would be. So I need to untab everything over. And you can do that, in a lot of different IDEs. I think you can do it in Replit, but you can highlight a whole block of code, and then you can hit either tab or shift tab to go either forward or backwards. So if you need to tab a whole bunch of code, like for example, you wrote some code and you're like, oh wait, I actually need to execute this under some other if statement, you can then highlight and tab something over or hit shift tab to bring it back. So in this case, I'm pulling my code back so I can execute it. And this time I'm going to say the word statement. And what I'm going to do, can I run this code as is right now? Will it work?
No, you haven't defined statement as a variable anywhere, I don't think. It
Oh.
looks that's why it's squiggly.
Yep. Yeah. So if you highlight over it, it's not defined. If I try to run this, I'll get an error, and it's going to tell me that the name statement is not defined. So that's a name error. So these errors you'll see quite often in your coding journey. They are descriptive. So I will need to make a statement here first. So I'll say statement equals content. And here, what's going to happen is I'm going to run this code. I'm going to say, hey, my variable statement equals content. And it's going to start doing a check. And it's going to say, okay, well, if statement equals happy. And so really behind the scenes, Python's doing this. Content, not statement. So right here, this if statement, does that equal happy? this is what's happening with that. Remember, because statement does equal content. I don't have to actually write the word content twice here because I define it as a variable. I can just reuse the variable name wherever I want to do the comparison. So that's basic script writing. So let me pull this back, and then I run this. And if you look, it starts here. Does content equal happy? No, it doesn't. So it's going to, then anything indented under this if line, it's going to ignore because that condition was not met. That condition equaled false. So this condition right now equals false. And then the next one is the else if statement. And it's saying, hey, does content equal sad? Well, no, that doesn't. So it's going to skip this line of code here as well, and then go to this. And this is the else statement. This is your catch-all statement. I don't have a condition after this one. So here I had a condition. So basically it's your last one. So your script doesn't just, you have to have a final condition for your script to run. I could just not include an else, but then I could be left with not getting any result because I have no other condition to go to. So this is a good one to kind of catch everything so then I can print I'm doing okay. And that's what happened in this case. Any questions on the if statement, else if, or else statement in that example? We good to go? Okay. So in these examples here, this does not include the else if. This is just an if and else. So you can just say, hey, if my condition is true here, execute here. If not, execute this code here. So this is a pretty basic, if and else statement. And here's the one with the else if. And here's a pretty good example too, showing, how you can evaluate a grade. If the grade is 85, it's going to take a look and compare this. So if it's greater than or equal to 90, print A. If it's greater than or equal to 80, really, you don't have to put between 80 and 90 because you're already checking to see if it's above or equal to 90. If that's not true, then it has to be under 90 and moves down. So that's also something to keep in mind with if statements. If you're checking for several conditions, you want to kind of take pause and just think about the problem and figure out, okay, what's going to be my most restrictive case in this example? Because if you don't put them in the right order, then you may end up with a weird result. And I can show that right here. Another code block. Print this. Then I will move this one. I think it's nope, like that. Hold on, I get used to my Mac. Nope, that's not it either. I'll have to figure it out. I'll just do it this way. Okay. All right. So what's going to happen here if I ran this code with my grade being 85?
It's gonna print C and B.
C and B.
No, it's going to be wrong. It's because you should have done B before C. Now because it meets the condition for C, it's going to print C and then it's going to stop. So that's not good. You messed up.
Yep. So yeah, I'm going to get an 85 being a C, which is not correct. And that's also something you could do. So you want to start with the most restrictive condition, of course, put the 80 above the 70. That way you can go down, start with the A and then go to B, then go to C, and then go to F. But if you chain your if statements, what's going to happen now?
It's going to do what the other guy said that was going to happen. The guy before I spoke up. I don't know his name. Sorry.
It's fine. It's a big class. I expect you'll get used to names after a while as we talk more in the chat room. But yeah, it's going to take a bit to know everybody's name. Right, but if I print this, it's going to evaluate anything that says if, it's going to evaluate. This typically is not good practice if not if the result or what you're checking is going to be only one condition. It's not really a good idea to chain just a bunch of if statements. You want to come to one final solution for it. So using that else if, the elif in there is really important to make sure that you can only go to one of those blocks unless your code is designed that way. There are situations where you will want to check for several conditions and do some stuff. That's just a different type of structuring, different way of structuring your code. But in this case, we're going to keep it to where we want to have one result in a bunch of different options, if you will. So let me put it back. There we go. Sometimes when you do this cutting and pasting, you'll end up with weird indentations. You just have to remember, go to your line. You don't have to highlight or anything. You just go to the line and press either tab or shift tab, and it should pop it over to the left or right as needed. And so now if I run this, I got the correct one because I started with my most restrictive, and then I went to the less and less restrictive options, of course. And if I'm below 70 here, then I get an F. Any questions on if, else if, or else this if else structure? Oh, I do have a question on this. Would this be considered one function? Okay, so Athena, you're saying would this be considered one function? This wouldn't be considered a function. This would be considered like a conditional tree or conditional statements. A function is written a certain way like this, where you're going to have a name of some sort with a parameter or input, and you get some output. So this isn't really considered a function. This is more of just a script of conditionals. Yeah. So everyone's answering that question too. Okay, so asking about when the if statements are changed. Okay.
Hey, Aaron, quick question.
Yeah.
For the elif, in this kind of situation, when there's multiple instances or multiple circumstances, we definitely want to use the elif, and then else would be used as the last, I guess, like the last line of defense, so to speak.
Yep. So the else is, hey, if because these already cover everything else. 100 is the highest you can go. So if it's greater than or equal to 90, stop here, print this A, and we're done. So now that's out of the question. So now the other possible grades, if I don't meet that one, are 89 and below. And so it's just going to keep going down until you're at you have 70 and above for this one, then anything below that, it's an F, and then that's the last condition. So this else is really the catch-all. So it's important to have that if your code calls for it. Most of the time, your code's going to call for an else statement. You're going to want to have some sort of default condition at the end. So for all the examples we're going to have, you're going to have a very structured if, else if, and then final else condition.
Thank you.
Yep. All right. I know it looks like we're going through this material really quickly, but the examples are really pretty well illustrated. I was going to use, so, in about 13 minutes or so, we're going to take a break, or in about, 10 minutes. I'm going to go over this nested if statements, and then I was going to actually build the example of the calculator. It's really going to take a lot of what you learned yesterday, where I just introduced a lot of those, strings and, the different, methods that we just touched on a little bit. And then we're gonna do a calculator. So we're gonna build a calculator using these if, else if statements. But let's move into the nested if statements, which is really great because it allows you to add some complexity into your decision making. Whether, like, let's say, for example, you have, you want to meet a condition for something, and this example is really good. Like, if you want to check for temperature, and then if you want to have, like, okay, it's definitely hot, but there's also, like, dangerous hot. And so you want to kind of get yourself into a branch, if you will, to determine whether it's going to be, hot or just, kind of warm. In this example here, we have, the temperature equals 30, and we're saying, hey, if the temperature is greater than 25, I want to go into this branch of code here. So that's all that's really doing, is saying, hey, I want to go into this branch of code right here if the temperature is greater than 25. And then run another if else statement. And so here I'm going to say if my temperature is greater than 30, then it's very hot. Otherwise, it's hot, but not scorching. And then otherwise print it's not too hot. And so in this example, just by reading it, what do you think we're going to get as a result? Hot but not scorching is we got a couple answers there. So let's run this, and it's hot but not scorching because we did meet this. This was our condition. We met that, and then we checked this, and we did not meet this. We almost met it, but not quite because we're not above 30. We're at 30. So it's hot but not scorching because of this else statement. Of course, if your temperature is 24, which I do work in Celsius in my my old job, I did anyway. But yeah, we typically don't work in Celsius here in the United States. I work in Fahrenheit, but 24 to me is definitely not hot. 30 degrees is definitely not hot to me either. So, oh, that's a good question. Jacob said, would a float higher than 30 meet the conditional greater than? Can we do comparisons between integers and floats? So like that. So 30.1. It is very hot. So yep, Python will compare a float versus an integer. But what if I did this? Would that work? Nika says no. No, that's
Nope.
string.
String.
Okay. Then if I run it, oh yeah, I get pretty nasty type error here. And then it says, okay, so the greater than symbol is not supported between instances of string and integer. How could I fix this by not removing the quotes? What could I do to make this work? I don't want to remove these quotes around this.
And cast one of them to the
I
other
can
type.
cast.
Yeah.
So I could do something like this. So what this is saying, hey, I want to make this an integer and then run it. So do you think this will work? Yes, yes, yes. If I run it, oop, doesn't work. Here we got a value error. It says invalid literal for int with a base 10, 30.1. What does that mean?
Int only doesn't work with floating integers.
Right. So I can't turn that into an integer because it has a decimal point. I would have to cast it into a float. So I can just put float in front of it and then run it. And now it works.
I'm sorry, Aaron. I'm a little confused of just because it's why when it's a string won't it work?
Why won't it work if it's a string?
Yeah.
A string. So I mentioned this on Monday, but I know I really we're going to go into a deep dive into strings in lesson 4. So but strings are not, they're not numbers. So it's really a collection. You can almost think of a string as kind of like a mini list of characters. So I could go in here and access any one of these characters by using the slicing. So if you want, I can show you by putting another code block down here. Another beautiful thing about Jupyter Notebooks is that the cells talk to each other. So since I've run the cell, I have temperature. I'm gonna run it again so it's actual strings. They did run it before. It was a I'm just gonna do this real quick. I mean, it's already there, but I'll go ahead and comment this out for now. Run it again. So now I have that in memory as temperature is a string 30.1. But if I want to pull out this decimal point or just view it or assign it to another variable, I can just look at it. So I can say temperature at the index of, what's this index? The first one?
0.
0. So we start counting at 0. So 0, 1, 2. So temperature at the index of 2, right? And I can run this cell and it'll should give me an output. And it gave me decimal point because that's what it is. So a string is a sequence of characters, but you can't do number like operations on a string. You have to first convert it to either integer or a float.
Okay, that makes sense. Thanks for explaining that.
Yeah, and that's some of the hardest things to think about, and that's where when we're talking about these basic data types, these are the basic data types, and you're going to get results sometimes that are defaulting to another different data type that you're not aware of. And you're going to have to think, well, what am I going to do with this data type? How am I going to change it? How am I going to change form? There's always a way to change the form of something. And that's what really, really learning like this very basic stuff and kind of almost committing stuff to memory, because this is like the equivalent of learning like very like basic letters of a foreign language of how this works, or how, what the verbs are of a language versus the nouns and so on and so forth. And so Athena has a question, says, I am lost. How is that a value of 2? This isn't a value of 2. I'm not saying that there's a 2 like a value. It's the position of this string. So remember, a string, much like a list, has things at certain indexes. So, right. So, yep. Jacob has a really good example. So the index 0 is the 3, index 1 is the 0, and then index 2 is the dot. And so when you're thinking strings, you have to think it's not a value, it's a collection of characters. And a list is a collection of objects, whatever you want in there. Could be integers, could be strings, could be other lists, but it's the positioning. So with that, we're at 6:57. Let's go ahead and take a let's take a 10-minute break, come back, and then we'll take these if else statements to another level by making a we'll make a calculator with it and kind of show you how to break these problems down. And we're going to run to some of these problems that I've just been talking about.
Hey, Aaron, could I ask a question about the assignment last night?
Sure.
So I struggled with it, starting from ground zero here, and
Okay.
so the course material I understand, but I really struggled with the format of what I was seeing on Replit.
Okay.
Um,
I can see it.
and
Yeah, it takes quite a bit of different concepts, and it tells you, hey, ignore these for now, and just if you put this right answer, you should get a true, and that's really what you're looking for, is you seeing the trues or falses. Yeah, I really wasn't. I wish we could have had a different way. You didn't have to comment code out to get to run, because the way they had it was, basically you have to have this. You have to have all of this like code written out before running this. So let me pull up Replit again.
so if you could, I mean, for instance, if you the first task, the very first one, if you couldn't get that correct, writing the code, you can't move forward with hitting run.
Okay. Yeah.
Even if you're looking at the answers, you know what it's supposed to be, but you don't. I mean, if you're not writing the right code to get to that answer, does that make sense?
Yeah. Let me.
I mean, I can look at the answers and see what it's supposed to be, but if I don't know how to write the code to get to the answer doesn't really help.
Okay.
Does that make sense?
Yeah, it does make sense. So right here. And so the first one said, hey, write a variable name fruits. And this is what you had. You had that, right? It says holding a list with the following values: apples, oranges, grapes, and pears.
Can't see anything. I just see you.
Oh, sorry, I stopped sharing, didn't I? Give me a second. I forgot I stopped sharing. Where's my Zoom? There it is. Share my right screen. You should see it just a second.
Yeah, I got it now. Yep.
Okay, so you were right here, right? And let me make this a little bit. I'm sure this is that pretty small for you?
Yeah, I got it. I can see it fine.
Okay, I'll just make it a little bigger in case someone else can't. Okay, and so you were here and you had fruits, and you're like, okay, what do I do? Is that basically where you're at?
Yeah, so I mean, I think I got that one right. But in general, just read it just with this format. The one that really got me was line 13. Um, I didn't know to put that hashtag there to for it not read. And I kept getting a syntax on line 12. But for instance, if for line 13, if I didn't know how to write that code in an exercise, I mean, I'm stuck there. I couldn't. When I hit run, it's not going to go anywhere past line 13 if I don't get that right. Correct?
I mean, it would still move. You could still remove oranges because oranges will already. If you got this one right, oranges would be in your list, and so you would get this one right. But yeah,
But it's only
some of them.
I mean, it starts with line 1 and runs until it runs into its first problem. Correct?
Correct.
So if I'm going linear and I get to line 12 and I write in my answer in line 13 and it's wrong, I'll never know if I'm not sure how to ask this.
So
if you don't know how to write the code, okay, say for 13, for line 13, I know the answer. You go to answers.py and look at it and get the final answer, but that doesn't tell you how to write the code to get to that answer.
Well, I mean, you would just, oh, I see what you're saying. Right. So this one doesn't tell you to write, the word append. And that's where you have to.
Correct. Right.
So those methods I talked about, and again, I briefly touched on them, and you're going to find a lot of these assignments here sometimes will go a bit beyond the lesson because what, I'm going to tell you right now, a good 70 to 80% of my job, my current job right now as a machine learning engineer and full stack developer, I do both. The majority of my job is Googling and looking for
Okay.
answers. And so a skill that you'll develop, it's called your Google foo, if you will.
Okay.
You can literally go to Google and say how
I did.
to.
Oh yeah, I did. I did 10 times for this exercise. The other thing that kind of messed me up is say look at line 15.
Mhm.
Um, that's not that's just for the exercise, right? That print test case 2 passed.
This is going, what this is doing is this right here is coming up with this is a conditional statement right here. This is what we're
Right.
learning today. This is just saying, hey, this is going to be true or false. If you didn't add it, then this is going to end up as false, and you'll get a false as a result in your answers.
Okay.
Yeah.
So are we going to use you said you're using Jupyter Notebook. Are we going to use Jupyter Notebook from now on, or when we go to our exercises, will they still take us back to Replit?
So you're going to use Replit for your exercises. I'm only using a Jupyter Notebook just so y'all can see the code a little better. I just found it to be a bit difficult,
Okay.
you know, because I'm a new instructor at Platoon. I went through Platoon, and then they had this new course, and I was teaching this content with NGA. This same exact intro level Python is more for data science, so it's a little bit different. But we use Jupyter Notebooks because Jupyter Notebooks are very prevalent in the data science field,
Okay.
but they're also very, very good to illustrate concepts because they break code down into blocks that are still tied together. So if you ran them linear, if I ran them top down, each one of these would almost continue the script, if you will. There's a Python kernel running behind this. I just find it a bit easier to teach with because I can
Okay.
keep a record of cells, go back, look at things. So you don't have to use Jupyter Notebooks. If you want to get familiar, you can go to just Google Jupyter Notebooks and you'll pull up
Okay.
it's an open source software, so it doesn't cost anything, and you can install it in your computer if you have it,
Right.
to run Python code, and then it's actually really powerful. I love them. That's
Thank you. Those good answers. Thanks.
Yeah. Okay. We still have a couple more minutes before we'll get back into it. Yes, and I am actually in VS Code here, and I'm running a Jupyter notebook inside of VS Code. But Jupyter notebooks can also be web-based as well. You can run it on a browser. Okay. Right. I hope everybody enjoyed their break. Um, any questions on the material so far? The conditionals, the whether something's truthy or falsy, or the if else statements or nested if else statements. Do you have any questions on that? Okay. So what I was going to do is kind of work through kind of like a guided
Hey,
exercise.
I'm so sorry, Aaron.
Oh,
We don't have to get into this now, but just when the group was discussing earlier whether it makes it a function or not, and you
uh-huh.
can't start and like this example right here, like grade equals 85, like that, or I'm sorry, or temperature, either one, like neither of those are functions. What makes it a function, as in like what what is that definition? If that so when you hit run, this prints out a result, but
Mm-hmm.
that's still not considered a function. So if that's not it, then what is?
So a function is a reusable bit of code that so a function, is right here. So this right here would be a function. They typically return something. So there's going to be a certain input, and then it's going to have a certain output. And really the keyword def right here is what defines a function. You'll have the function definition, and you'll have the name of the function, and then you'll have an input. And really, remember when I talked about the print statement? So right here, this print is a function. So print is a function that's in the Python code behind the scenes. You can't see it. There's a whole bunch of them. There's len for like length of a list. There's type. So when I run type, it's going to take whatever I'm taking as an input. So I'm going to say print, right? Print, I'm doing okay. And so if I meet this condition, then I'm going to call the print function. And then there's Python code, even really Python's written in C. There's code in the back end where you can't see behind the scenes that's going to tell your computer to print something to the console. And that's what that's doing there. So functions are called by writing the name of the function and then putting your parameter in. In this case here, in my super awesome function, I'm calling my function right here, and then I'm giving it a parameter, which is sad. And then basically parameter, the word parameter equals the word sad when I call it here. But I can call it again. I can just call it again right here.
So oh. So now if you run, your new function is going to be happy for super awesome function rather than sad. Like that is your new parameter for my super awesome function.
Right, so it's gonna be both. So if I ran
It's
this
still going to be
right
both.
now, I'm gonna get back I'm sad for the first call, and then I'm gonna get, yeah, I'm pretty happy now for my second call because
Okay.
I'm calling the function twice. It's
Okay.
reusable code.
Yeah.
That's what a function is. I can't call this twice like I can with a function. I can't unless I wrap it into a function. If I turn this into a function, I could, but it's not
Gotcha.
a function because it's not defined as anything.
Okay. Thanks, Aaron.
Yep, you're welcome. Cool. So let's think about, I want to kind of build a calculator using only strings. And so if we take this problem and we say, okay, we have an input string, and it's going to always look like something like this. It's either going to look like this, or let me see here. Here we go. Let's just do another one, and we can say 17 minus 6, something like that. Um, I want to evaluate this statement and then make a Python calculator out of it. And if, we think about this and we think about data types and everything else, like how can I approach this problem to even start to do a calculation? I mean, we can do calculations. I can take an integer and then do like a subtraction or addition, and we'll just do addition and subtraction or anything other more complicated than that right now. But we can do that with integers, right? We can write a block of Python code that will, take a number. So I can easily do that. So 17 minus 6, for example, here. And if I ran that, I get 11. Okay, I can do that. But how can I write a Python script that will take a string and do the operation? What do we have to do with this data first before we get to doing calculations? Okay, so I'm getting lots of answers here. Okay, so it looks like split it to make a list. We can change the type, convert to a float integer. Okay. Okay. How can I get both of these numbers out of here? If I were to write one script that can handle anything I throw at it, like let's say any 2 or 1 digit number, any float, or any number possible, right? So I want it to be able to handle not just 8 plus 7. I want the same script to be able to handle 8.5554 plus 765.
F string.
Okay, F string. Do we talk about any other kind of methods to like maybe divide up a string?
Use a comma.
Splice. Okay. Or split, right? We can do split. So here we have input. Okay. And then we can designate inside the split one, we can actually designate a character. So we can say plus right here, and then we can then try and see what the result is there. And if I ran this, hold on. Let's do, no, you can't do it that way. Do this way, print. It could be like this. There we go. So if I were to run the split function, I actually get a list now with 2 numbers. And I can then perhaps maybe take that data and then turn that into something later on down the road. But remember, we want this calculator to kind of do any mathematical operation, but we have to kind of know what we're dealing with. We know that there's a plus sign here or a minus sign, but Python only knows it as being a character. So we can then maybe try to identify what problem is in there or what mathematical operation is in there by using an if statement. Remember, a string is a collection of characters. So my string is it's going to have a bunch of numbers and stuff, but it's okay. You got okay. There we go. So I'm going to have a bunch of characters in a string, and I'm going to want to split them up. Well, I'm only going to have one of these. I'm going to have only one of these characters, either a plus sign or a minus sign. That's it. I'm not going to have any more because it's going to be just 2 numbers. So I could say, okay, well, I can say if input string let's see, if plus in input string this is addition, And then what could I write next? Should I do, let's do else, because really we're only doing addition or subtraction, right? So I could say print this is subtraction. Okay, so we're making a decision on this alone right now. We're not gonna do anything else. We just want to see what kind of problem this is. And so if I ran this, it says this is addition. And if I were to put a minus sign in there, it's gonna tell me this is subtraction. So I can kind of identify with Python what I'm going to do later on down the road. Again, this is, we're trying to break this problem. We're trying to turn a single string into a calculator that we can do some mathematical operation on. And so right now we're just trying to see, okay, well, we can write it another way as well. We can say elif oops, I have a single. There we go. We could also do it that way, and it'll work as well. So we can use either if or else because we're only doing addition or subtraction. If we wanted to add other ones, we can just use elif and add the symbols. But for this example, it'll take too long. So in this example, we're just going to stick with, if the plus is in the input string or if minus is in the input string. So now we know we can do that. We can figure out what kind of operation we have. We want to kind of keep that in mind, but we don't have to keep this print statement here. We can define a new variable to put that list that we want to make. Remember how I printed out the split? I can also make a variable. So I could do this. And now I have numbers and I'm running a conditional based on what I have in this string right here. So whether it's a plus or a minus, I'm going to split the numbers appropriately. And I'm always going to split them on wherever that character is. It doesn't matter if this input string is here, if it's going to look like that, or if it's going to look like that. It doesn't matter. It's going to always split the string and give me a list of numbers. And I can show you here by just pulling out numbers and running it. I now have a list with my two numbers. And one thing I didn't cover on Monday is, you can run an addition operation on strings, but all it's going to do is concatenate them or put them together. It's not going to actually do any mathematical operations. So right now, if I had, if I have a two strings and I want to just put them together as one long string, I can use the addition operation to put them together. But we don't want to do that. We don't want to put numbers together. We actually want to do a mathematical operation. So what would our next step be at this point?
To actually subtract them?
Yeah, what would our next step be? So now that we know with this logic right now, I can get one input string that is one string. I'm going to identify whether there's a plus or minus in there, and then I'm going to split them into a correct list of strings. What's my next step now? Okay, Tim says now convert to an integer or float. Okay, let's do that. So like instead, now so we know we're going to end up with a list of two values, whatever values there are. They're always going to be split on the correct mathematical operator. Let's just make two new variables, and we'll say num1, and we'll say we want to access the first number. How do we access the first item in a list?
Index.
The index, right? So I can say numbers at the index of 0. And then number 2 equals numbers at the index of 1. That would be the second number. I'm always going to end up with two numbers based on how we're doing a simple operation like this. And then I can go ahead and print num1, num2, like that. And if I ran this, I'm getting two numbers now, two separate numbers.
I'm sorry, this might seem like a stupid question, Aaron, but
yeah.
when you're for number 1 and number 2, does it make a difference when, like, by putting numbers like plural, that makes it pull the entirety of the number rather than just putting number? Like if you put number and then index 0, does that just pull 8 rather than 856?
No, so that's a good question actually. I'll go there first. So when I'm saying numbers, I'm referring to the list that this right here is going to make a list of two values. So this dot split is going to make a list. And so it's going to be a list called numbers. It's a new variable. So I'm making a variable called numbers and it contains a list. So if I were to print it right here, right? So this is my list of numbers, right? All I'm doing is I'm accessing, I have to say numbers because numbers
I
is the
see what you mean.
variable. Yeah,
I
yeah.
see what you mean.
Now, if I wanted to access just the 8, how do you think I could access just the 8?
I kind of thought that's what we were trying to do with that. I don't know.
Someone asked me to print the type real quick. So I can do that right here. And it's a list. So you could always figure out, okay, it's a list. Okay. Well, you can do indexing. So if I want to find index 1 of numbers, I can say find the first index. That would be the number 5. So let me comment this out here. Actually, leave that one there. Print. Okay, there we go. See that 5 comes up right there? Because that's numbers at the index of 0, which is 856, and then I'm going into the second character in the string 856, which is the 5. We will go into nesting later on, but that's kind of how you access that. But anyway, we're going to keep it there for now. So there, I have print number 1 is 856, and then numbers at the index of 1. I'm going to print that as well, or print number 2. And I'll run that completely. And now you can see I have a list of two numbers, and then I'm printing the first one. I assigned it to the first index of numbers, and then I'm printing it out. And then I'm assigning the second index, or the index 1 of numbers, to number 2, and then printing it. Any questions so far on using some of this, accessing indices, or kind of where I'm going with this calculator so far? Oops, I'm gonna Command Z that. I want to keep that right there. All right, I'm gonna get rid of some of these print statements so it's a little cleaner. Okay. So now we have our number, but the problem is our numbers are still strings. So if I were to print like that, okay, we know this is going to be a string. If I were to print that, it's just going to put those two numbers together, 85634. It's going to basically take 856 and the string 856, a string 34, and just mash it together. So we got to do something else. What can we do with number one and number two? We did it before. Yep, we got to cast, right? We got to convert the data type. So we're going to take the string, and we know they're strings, and we just attempted to try and add them together. So we want to change them. So we can just say, okay, well, let's do int. Comment this out so we don't see it for now. But we will print. Okay. So now we should see at least the type of number one as we go through. I run that. Looks like I printed the type of number one here, and it was a string, and then I cast it. So I said, okay, well, I want to make it an integer. So I cast it into an integer, and that's what I get. So I have an integer. So I should be able to do a calculation now. I think, anyway. So let's see here. Let's just do addition for now, which is subtraction. We can do it that way. We can at least check to see if it's working. And it looks like it is. It's giving us a final result. So let me go ahead and close that. But that's not what we want to do. We want to take that operator and use that after all this, so we don't have to actually explicitly type this. I don't want to have to type a minus sign or a plus sign. I want it to kind of do it automatically for me based on whatever I have. So, and then also, what if I have a float in here? So what if I have 0.3 and I try and run this? I'm going to get an error. And we've seen this error before. Whenever I was trying to cast a string representation of a float into an integer, I couldn't because I had a decimal point in there and it wouldn't work. So I would have to then maybe think about, well, can I cast
You can change it to float.
I can just cast everything to a float, and that way I know I'm going to get a good calculation, right? Because the float is kind of like almost like more restrictive data type. Not restrictive, but it's more precise. So if I did that, but I had only integers, it would still work. It'll still give me a result. It's just going to be in the form of a float. Yeah. We want to cover all use cases. So I'm trying to make a calculator that covers any use case that's thrown at me with only one type of code. So this is kind of like the rub when it comes to coding is how can I come up with this solution to a problem where I can almost cover all conditions. And thinking about, yeah, easy, all integers and, plus or minus sign. Okay, that's easy. But what if I throw one float in there or a negative number? What happens then? Now I have two, minus signs in there. Yeah, what happens? That's a good statement. Like, what happens if the number is just gigantic, and it's too big for, uh, the language to handle. I know, like in Java, you have doubles and you have big ints, big integers and stuff. And if you have those issues, you have to kind of think about, and also in SQL, you have to think about the type of number because there's limitations on how big your number gets. Right. In this case, we're just doing a simple calculation. So we could almost say, okay, well, we can almost do another. So we want to actually do the mathematical operation now. So we can just do another if else statement and just kind of almost repeat this part here down here. So let's use command and not control because go ahead and put our parentheses around that. Right there. Let's get rid of this. Okay. Try running that and see what we get. Okay. So all I did here is I kind of did the same operation up here when I was looking for the symbol, either plus or minus symbol, and I split on either the plus or minus depending on what's in there. Then I assign my numbers, and my number one is going to be numbers the index of 0. Number 2 is going to be numbers the index of 1, and then I'm going to cast them into a float. So each time number 1 is now cast into a float. Number 2 as well. And then I'm just going to do that. I'm going to do a check for the input string again to see if there's a plus or a minus in there. And I'm going to do the appropriate operation based on whatever I find. And this time I was like, well, I know that I don't have to type it all the way out like this because I only have 2 options. I have either plus or minus. And if it's not plus, then I know it's minus. So I didn't even have to put that minus conditional in there. I can just say else. And then I can say print num1 minus num2. And so now I can go ahead and try and put in anything to just kind of test it out, see if it still works. So I can say 54.3. Let's do a plus here. Let's do 900 or 9,087. And then I run this. Looks like it works to me. So this is so Athena, I just so I mentioned that. So I said, hey, I could write it this way. There's nothing wrong with writing it this way, right? But if like in the restrictions of my problem, I said, hey, I want to write a calculator that does plus or minus only, right? So in my problem, I said, hey, it's only going to be plus or minus. You're not going to get any other condition, right? That's all I cared about. And so I could write it this way and say if plus is in the input string, then do this. Or if minus is the input string, then do this. I could also say if plus is the input string, do this. Otherwise, do that. So I was just illustrating that you could write it either way and still come up with the same logical solutions. You'll find that right, so you could use else. Well, I mean, else means in any other condition, if so basically it's almost as if the plus is not in there, then do this other thing, right? But we know in the conditions of this exercise, it's either going to be plus or minus and nothing else. Yes, I could have a I could have a divide symbol in here and it's just going to do the subtraction because the plus is not in there, so it's just going to go default to that. I could do that.
Hey, Aaron, good question.
Yeah.
In this calculator example, if we wanted it to include also multiplication and division and, absolute value and power of whole numbers, essentially we would just have to kind of copy and paste that first part and then include the symbols for multiplication, division, and then that way, if we were to enter that kind of operation into the very, very, very beginning, it would just run it essentially, and we would have like our own little mini calculator.
Right. If you want to get more complex with your if and else if statements, you can throw in multiplication or division in there, and then you would do the same split based on whatever your symbol is, and then you would then for your mathematical operation you would have to have if it's a plus do addition, if it's a minus do minus, so on and so forth. Yeah, you would have to still
oh, that's so sick. That is sick.
Yeah, so and this is just a simple turning a string into some numbers and doing the mathematical operation in where are my numbers? Why have my numbers on here? I have to figure out how to put my line numbers in here. Here it is. Toggle, no. I can't remember how to add line numbers on here for now. But yeah, it's a short little problem, but it kind of shows the logic flow. You would go from top to bottom, how we're changing types. We're finding things in a string to split and turn into a list, and then converting those list members into floats, and then finally doing the calculation on those two floats that we defined as variables here. So that's really the essence of breaking your problem down into solvable steps, and then using these conditionals, which is what the topic of this lesson is, to make decisions in code and come up with certain solutions. So that's really the end of the lesson. We built this calculator, using casting, using the if and else statements, making decisions, determining whether something is true or false. That's really the small part of it, and this is all the very basic foundation of coding. And you're going to start, once you start getting into it and doing it more and more, this stuff becomes so natural to you that you'll start just throwing it together and then constructing more and more complex operations. Let me see if I'm going to have to go to the GitHub page. Give me 1 second. Oh, no, I don't want to look at that. Let's see here. Give me 1 second. I'm going to go to the GitHub page. Okay. Any questions on any of the topics we talked about today? Okay. Let's look at the assignments in Replit. We're going to spend the rest of the time really just in office hours. We'll take a break here in about 15 minutes, but we're going to take a look at these exercises here. And I would like just to spend some time in class doing that. We have a couple TAs here. I think I saw Mike Zira answer some, and then I did see, where is it? I did see Philip in here too. Yep, there's Philip right there. So they're available as well to answer questions, but we're really going to spend time doing these, doing these problems here in class, and we can answer questions. I am going to go ahead and stop the recording because I'm pretty sure you don't want to watch yourselves talk about questions over and over again and just get to the meat of the problem. So I'll go ahead and stop the recording here.